Hello everyone, today we're going to go over the Blind 75 in C++, and today we're working with longest common subsequence. Now, before we get started, feel free to pause the video or follow along accordingly. For whenever we are breaking down these questions, we ask ourselves these 4 questions: what the input's going to be, what data structure / algorithm / technique to use, what to do with the data, and finally, what our output is going to be. So let's just break it down. Alright, so now just break down the problem. Given two strings, text1 and text2, return the length of their longest common subsequence. If there's no common subsequence, return 0. Alright, so we already know what our input and output is. This is our output. If there's no common subsequence, return 0. And remember, we're given two strings, text1 and text2, right here. And we need to return the length of the longest common subsequence. So that's the first one, return the length of their longest common subsequence. And the technique that we'll be using for this following solution, if we're going over the examples, namely, what we're trying to do is that we're trying to find the longest common subsequence between the two patterns of two different texts when we're scanning both of them accordingly. And the technique we're going to use is dynamic programming. To scan both text 1 and 2 using a dynamic programming table to check for character and size of our text strings. And the steps for us to be able to go about this are for the following. So step 1, we're going to initialize a DP table with the size of text1 dot size plus 1 times text2 dot size plus 1 and when we do so, this is how we create our table. Then what we will do is that for step 2, we're going to loop through each character in both strings. And then for step 3, if the current characters in both strings are the same, the value of the current cell is 1 plus the value of the cell diagonally of the table, both above and to the left of it. And for step 4, if they are different, the value of the current cell is the maximum between the cell to the left and the cell above in our dynamic programming table. Finally, for step 5, we're going to return the value in the bottom right corner of the dynamic programming table we created to show the longest common subsequence. And I'll also have a visual as well for the dynamic programming table while we are constructing this whole behavior. Now, just to clean up everything else and just go straight into the code over how it will look like. So I'm just going to write the steps, just 5 steps accordingly. Step 1, step 2, step 3, step 4, step 5. Let's just get after this. So first things first, we're going to create our table. This is how we do so. We're going to do a vector int, dynamic programming, text1 dot size plus 1, and then we're going to have a vector of int measures representing the character size for each strings, text2.size +1. And now we're going to loop through each of them. So the way we do this is that we're going to have two nested for loops. Int I is going to be 1, and then I is less than or equal to text1 size I++. Then we're going to do another nested for loop for our following. Instead, it's going to be j is equal to 1. This is representing text2 less than or equal to text2.size j++. Then we will do steps 3 and 4 on the inside of it for if-else statement. If. And finally, for step 4, that's going to be our else. So, step 3, if the current value in both strings are the same. So if they are the same, we're going to have text I -1 equal text2 j -1, and then dynamic programming of I and j is going to be equal to the dynamic programming array if they are the same. So we're going to subtract from 1 over here, and then j -1, since we're scanning both, +1, make sure that they're the same. Then we increment, and then if they are different, this is how it's going to look. dp of I and j, we are scanning them, we're just going to get the max value between them. So I -1 j, then dp I and j -1. And finally, we're going to return the value at the bottom right corner of the dynamic programming table. So we're going to do this return dynamic programming text1.size for the following, and then we're going to have text2.size for the next following as well. So let me just make sure everything is already lined up and it's correct. Text1 size, text1, text1, text2. Alright, let me just double check. Alright, we got a syntax error over here. I forgot the semicolon. Small things like that. And I apologize for this as well. Text1. There we go, passes all the test cases, and we submit. Okay, and now just give a rundown on the space and time complexity for our following solution. Is that the time complexity for our solution is going to be O of m times, it's going to be O of m and, it's going to be O of m and n, where m is the length of the first string and n is the length of the second string. This is because we fill up our dynamic programming table of size m times n, and the space complexity for our following is also going to be O of m times n for the same reason. And yeah, so this was Longman's common subsequence. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.